The range and the maximum range is a pretty important one. It's a very important one to be comfortable with. So you're comfortable with the range, that's fine. So that's time, that's the S of x when t is at a time of flight. So time of flight is equal to, what is that again? It's well, it's when sy is, so it's u sine alpha. So if that's alpha, u sine alpha over g, I think. And then your range then is equal to what is it? It's the 2u sine alpha cos alpha over g. So that's also, oh yeah, so it's the range actually is equal to u squared, 2u squared. So it's when you plug that into your s of x. So you get that guy. And then you can use a trigonometric identity to get rid of this and convert it into r is equal to u squared sine 2 alpha over g. So it's important to understand that one, and I think that's fine, the range. Now, to maximize that range, what would you do? Well, can you do anything with u? No, that's a constant. Can you do anything with g? No. So it's about maximizing that. So how do you maximize any sine? Well, any sine, no matter what it is, sine z or whatever, has a maximum of 1. So it goes from -1 to 1, any sine at all. Doesn't matter what the angle is. So you could, if you like, do dr d alpha and set that equal to 0 to get your maximum range. Okay, you could. Let's have a look. So dr d alpha would be equal to, so differentiate that. So it's cos 2 alpha and 2 comes out, 2u squared over g. Set that equal to 0. So cos of 2 alpha, when is that 0? Well, that's when 2 alpha is 90 degrees, so you get alpha is equal to 45 degrees. But the other way, simpler way of doing it is, you could just look at that and say, look, what angle of so the only variable is what's that maximum in order to get that maximized, because you can't change these constants, and it turns out the maximum sine is always 1. So it's r is equal to u squared over g. So we're just dealing with the sine now, we're not even drilling into the angle. What's the maximum value of any sine? And it's 1. So later on, if we wanted the angle, and I think in this case, they might be asking for what the angle is, but we'll say, look, what value of sine alpha, sine 2 alpha gives you the 1. And it's when 2 alpha, or whatever the angle is equal to 90 degrees. So alpha is equal to 45. And intuitively, we know that if we're throwing a ball, if we throw it nice and really low to the ground, say about 10 degrees, it's not going to travel very far. If we throw it too far up, then we're trying to get too much height out of it, and it's not going to go very far either. So the Goldilocks happy medium is where we're throwing it between the 90 degrees and the 0, and so at 45 degrees, at 45 degree angle there, you get your maximum range here. And that maximum range is when that sine thing is at its maximum. So what's the minimum of that, of a sine? It would be at 0. So that will give you a minimum range, which is trivial, because that would mean if you threw it at an angle of 0, you get 0 range. It just doesn't go anywhere. So you're trying to get the maximum. So the only variable, just hone in on what's the one you can do anything about. Can't do anything about u, can't do anything about g. Hone in on this. What's the maximum a sine can be? And it's 1. So that gives you u squared over g. If you need to know the angle, then you say, what angle do you need to get that sine 2 alpha equal to 1, which is down here, and you get 45. So that's a very important one, because that comes up quite a bit in applied maths. And also, it's just an important good one for minimization, is maximization and minimization. They will ask those kind of things quite a lot. So be able to look at a chunk of variables and be able to see how would I maximize this. And usually there's something screaming out like a trigonometric function. Or you could differentiate as well. So differentiating that, you ended up with the sine being equal to 0. So now you're trying to say, and it doesn't matter what constants before it, that has to be now 0. So that leads to an angle of 45, which is the same as what we got here down here. All right. So hopefully that clarifies how you maximize the range of a projectile.